Today we are going to start with the third unit of antenna and microwave engineering. So in first unit we have studied the basics of like microwave engineering and the basic parameters of antenna. And second unit we have studied the design uh, uh, aspects of the antenna, right? And its radiation pattern and some types of antennas we have studied in second unit, right? So in third unit, we are going to study with the antenna arrays and applications, right? So here we need to study two element array, then array factor, pattern multiplications, then uniformly spaced arrays with the uniform and non-uniform excitation amplitudes. Then and last topic is smart antennas, right? So in first topic is the two element array. Also, we need to study n element array, right? Uniformly spaced arrays with uniform and non-uniform excitation is actually n element array, right? Then the parameters like array factor, pattern multiplication also we need to study here, right? So array antenna, what is an array antenna? We need to know, right? So in second unit, you might have studied about the single antenna and its radiation pattern, right? Single antenna element and its radiation pattern. So here, if you want to get improve directivity and gain, then we can arrange more number of elements in a certain pattern, and we combine the radiation pattern of all the antennas, right? So that we can able to get better directivity and better gain, right? So gain in the sense, so directivity highly directed towards a particular direction, right? Or in simple terms, we can say that antennas are here rearranged and in required and effective ways to earn directivity, right? So here more number of antennas are combined and their radiation pattern or radiation is also combined to get better directivity and better gain in a particular direction, right? So in the diagram, you can see some examples of this arrays, right? So the first diagram, you can see array of microstrip patch antennas, right? Array of microstrip patch antennas. So in second unit, you might have studied some microstrip antenna, a single microstrip. So here in this example, you can see four microstrip antennas which are fed with a source or excited with a source, right? So that the directivity can be improved. And the second diagram, you can see that four helical antennas are arranged in a particular manner, so that its directivity and the gain can be increased, right? So when we are arranging these arrays, we can arrange in different ways, like linear array. Linearly, we can arrange it circular or star. In different pattern, you can arrange it. So uniform linear array means, so all the antenna elements are arranged linearly in a straight line with equal spacing. We will arrange it. That type of arrays we call as uniform linear array. Linear array means they are arranged in a straight line with equal spacing. Uniform linear array means all the elements are fed with equal amplitude and in same phase. We call this uniform linear array. So if these elements are arranged in a circular fashion, we call this uniform like a circular array. Or we can arrange that in star fashion. So then it is called as a star arrays, right? So array means like combining or arranging n number of elements and combining the radiation pattern of all the antennas to get better directivity, right? So here we can achieve high directivity in a desired direction, right? In a point-to-point communication, so we need to transmit the maximum energy towards a particular point, right? In a point-to-point communication, we need to get maximum directivity in a particular direction. So in that case, we can form an array antenna and we can achieve high directivity, right? So this and it is used in point-to-point communication or long-distance communication, right? So if you increase the gain by combining all the arrays, we can able to transmit the signal to a longer distance with high directivity, right? Then narrow beam, we can form narrow beam with, if you combine more number of elements, then we can achieve narrow beam. You can see that in the diagram. Then it can provide diversity reception. So it can provide, if you are forming an array antenna, it can used for diversity reception. This you might have studied in wireless communication last semester, right? Wireless communication last semester. So in the design of receiver, so the quality of received signal can be improved by three methods actually. The quality of received signal can be improved by three methods. In normal wireless communication, so the purpose of transmitter, you already know it. It is just to transmit the signal in free space, right? But the responsibility of so quality reception lies on the design of receiver, right? The quality of the complete communication system, so mainly rely on the good design of the receiver, right? The responsibility of transmitter is just to transmit the signal in free space. So it travels through the free space, it interfere with noise signal. So when it comes to the receiver, it comes along with the noise. So the receiver has to remove the noise and it has to recover only the desired information signal, right? So simply it cannot receive that signal. So we include more number of blocks, particularly in the receiver, right? So one is the design of filter. The main component in the receiver is wireless communication receiver is filter, right? That actually separate the particular band of signal. Then we'll make that signal undergo in a different process, right? The quality of receiver lies in first one, the good filter. Then additionally, we include more three important techniques. First one is adaptive equalization, right? Adaptive equalization. Second one is we call it as diversity techniques. The third one is pre-coding technique. That you might have studied in wireless communication last semester. So adaptive equalization is nothing but using an adaptive filter bank. So now you know the function of filter. So filter removes unwanted noise signal, right? Unwanted noise signal with the desired cutoff frequency. Normal filter cutoff frequency is static. But in wireless communication, we don't know the behavior of communication channel. So in the noise add on, so we normally include an adaptive filter. So adaptive filter na adoda cutoff frequency ella channel condition change aayittu, right? Adukku nare algorithm irukku. Here we don't want to study all that. And in equalization, we use adaptive filter bank, right? Adaptive filter bank to remove the maximum possible noise and extract the good quality signal. And second technique is we call it as a diversity technique, right? Diversity technique. Diversity technique is diverse. We know it, different forms, right? So instead of transmitting a single signal, we used to transmit multiple copies of the same signals, right? Multiple copies of the same signal through different antennas, right? Through different antennas. So in receiver, we'll receive all the multiple copies. We combine it. For combining, we have a separate algorithm. So in the diversity combiner, it selects the quality signal, right? So in the diversity technique, we assume that by sending multiple copies of the same signal, any one copy come to the receiver in good quality. So under that assumption, we are doing this diversity technique. So in the receiver, we'll compare all the received signal and we'll extract the good quality signal, right? To receive all the multiple copies, this array antennas can be used. The array means multiple elements, right? Multiple element antenna can be used in the receiver, right? Then another important function is it can be used to remove or cancel out interference from a particular set of direction, right? So if you want to receive the signal only from a particular direction, so along with that signal, the other direction also we will receive some signal. So that signal may interfere with the main desired signal. So if you use multiple elements, there is a possibility of cancelling those interference, right? Then it is also used to determine the direction of arrival of incoming signal, right? It is also used to determine the direction of arrival of incoming signal, like radar antennas, right? By using multiple elements arranging in a particular fashion, we can able to determine the direction of arrival of the incoming signal. So all these above what the functions can be achieved by actually two methods. So all the above function can be achieved by two methods. One is by increasing the size of antenna, right? By increasing the size of antenna, right? Increasing the size of the antenna is not effective practically. Increasing the size of the antenna is not effective practically, but arranging the smaller elements to form an array is quite possible, and it is highly effective, right? So this above function can be achieved by increasing the antenna, which is practically it is very not effective, but antenna arrays is highly effective, right? So normally we go for array antenna, right? So this is again an example of arrays. So in microstrip satellite receiver, so they use an array of microstrip antenna, and they are excited with the source. If it is used in transmitter mode, it will be excited with the source. If it is used in the receive mode, that will be connected to the receiver, right? Each antenna will be connected to the receiver. And second diagram, you can see the crossed dipole in FM broadcasting. In FM broadcaster, they will be using array antenna. There they will use cross-coupled antenna in a different direction. Right? They will connect this cross-coupled cross dipole antenna in different direction. Right? So here the main concept of array antenna is we are arranging different arrays, different elements in a different fashion, and we'll combine all the antenna so that the pattern they can add vector summa varum the total pattern of the combined array can be the vector sum of the individual radiation pattern actually, right? So antenna array is a set of multiple connected antenna which work together as a single antenna to transmit or receive radio waves, right? The same excitation is given to all the arrays, right? So by combining all the elements, so it actually works as a single antenna. In FM broadcasting, the purpose of FM transmitter is to transmit the particular channel, right? So the maximum preference is that signal should reach maximum distance. If you are installing that FM broadcasting antenna in Chennai, it has to reach maximum distance. So the directivity and the gain can be increased by like combining multiple elements rather than using a single dipole antenna, right? So the antenna array is combining more number of antenna elements and the combining to form a single antenna, right? So in the preferred direction, we can able to achieve high directivity and gain, right? While the radiation can be cancelled in other direction, right? The directivity can be increased, and the gain means, so directivity means the maximum radiation is towards a particular direction. So gain increased means it can reach maximum distance towards that direction. So these two functions can be achieved by array antenna. So array means the same type of element, other multiple element we are arranging, right? Over antenna we will fed with the source. Each antenna will be excited, right? Different types of arrays. And the basic principle of antenna array is the total field of the complete array antenna is determined by the vector addition of individual elements. Vector addition of individual elements, and the field from the elements of the array interfaces add in the desired direction, and it cancel in the remaining spaces, right? So they constructively all the radiation from individual elements constructively add in the desired direction, right? Their phase angle will be additive, so they add in particular direction, and the remaining direction they cancel each other, right?